In 1937, as Europe teetered on the brink of war, British military planners faced a critical problem. Their tanks were equipped with the Vickers machine gun, a water-cooled weapon that had served adequately in the trenches of World War I, but was proving hopelessly outdated for modern mechanised warfare. The Vickers required constant maintenance, its water cooling system added weight and complexity, and mounting it inside the cramped confines of a tank turret was a nightmare of engineering compromises. Something had to replace it, and quickly. What emerged from this urgent need was one of World War II's most unlikely success stories. A Czech-designed machine gun that fired German ammunition, built by British factories, and mounted in virtually every British tank that would rumble across the deserts of North Africa, the hedgerows of Normandy, and the hills of Italy. This is the story of the Besa machine gun. The journey began not in Britain, but in the workshops of Zbrojovka Brno in Czechoslovakia, where firearms engineer Václav Holek and his colleague Miroslav Rolčík were working on a replacement for the obsolete Schwarzlose machine guns that had served since World War I. Holek was already well known in firearms circles. He and his brother Emanuel had designed the ZB Visas 26 light machine gun, a weapon so successful that Britain had licensed it and put it into production as the legendary Bren gun. Now, in 1930, Holek turned his attention to creating a medium machine gun suitable for both infantry and vehicle mounting. The challenge was considerable. The weapon needed to be air-cooled, eliminating the weight and complexity of water cooling systems. It had to be belt-fed for sustained fire. It needed to be reliable under harsh conditions, and most importantly for tank use, it had to be compact enough to fit inside armoured fighting vehicles while still delivering enough firepower to suppress enemy infantry and engage lightly armoured targets. The early prototypes went through numerous iterations. The ZB-50, developed in 1930, used water cooling and was quickly abandoned. The ZB-52 of 1933 moved to air cooling but wasn't reliable enough, particularly at higher rates of fire. Finally, in 1934, the ZB-53 emerged. This design incorporated everything Holek had learned. It was gas-operated using a long-stroke piston system derived from the successful ZB-26 light machine gun. The barrel was heavily finned for air cooling and could be quickly changed when it overheated. The weapon used a tilting bolt locking system that was both simple and reliable, and crucially it featured an innovative rate of fire selector. By engaging or disengaging a spring-loaded buffer in the path of the recoiling bolt, the operator could choose between 500 rounds per minute for sustained fire at longer ranges, or 750 rounds per minute for close-in anti-aircraft work or immediate suppression. The Czechoslovak military purchased 500 of these ZB-53s in 1935, designating them the Visas 35, and put them through extensive testing. The guns proved reliable, but the army requested improvements. Holek went back to work, and in 1937 the final version emerged, officially adopted as the TK Version 37, meaning Heavy Machine Gun Model 1937. This was the weapon that would change everything. The Vision 37 was chambered for the 7.92 by 57mm Mauser cartridge, the standard German rifle and machine gun round. This was practical for Czechoslovakia, whose entire military was standardized on this caliber. The weapon weighed about 21 kilograms without its mount, had an overall length of 1,100mm with a 740mm barrel, and featured a distinctive appearance with its heavily finned barrel, folding spade grips and robust construction. It could be mounted on tripods for infantry use, installed in border fortifications, or adapted for vehicle mounting. Production began at the Zbrojovka Brno factory, and the weapon was also exported to Romania, Yugoslavia, Iran, China, and other countries. But in Britain, military planners were watching Czech firearms development with great interest. They had already licensed the ZB-26 light machine gun as the Bren, and it was proving to be one of the finest weapons of its type in the world. When British officials learned about the ZB-53 medium machine gun, they saw a potential solution to their tank armament problem. In March 1936, the British government ordered 2 examples of the ZB-53 for testing. The cost was £392 for the vehicle-mounted version and £880 for the infantry version with tripod, equivalent to roughly £23,500 and £52,800 in 2024 values. But there was a complication. The ZB-53 was chambered for the 7.92mm Mauser round, while British forces used the .3-3" rimmed cartridge. Introducing a new caliber would create logistical nightmares, requiring separate ammunition supplies, different loading equipment, and extensive retraining. The Czechs anticipated this concern and proposed a solution. They would produce versions of the ZB-53 rechambered for the British .303 round. A pilot model was manufactured and demonstrated in the UK in April 1937. The British were sufficiently impressed that they sent it back to Czechoslovakia for full-scale manufacture. In October 1937, two ZB-53s chambered for .303 arrived in Britain and were subjected to acceptance trials that November. The results were exceptional. The weapon achieved a stoppage rate of just 0.5%, meaning it jammed once in every 200 rounds fired. This was extraordinary reliability for a machine gun of that era. The tests showed the gun was accurate, robust, and well suited for tank mounting. It appeared that Britain would adopt the .303 version, maintaining ammunition commonality with the rest of their military. But fate intervened in the form of bureaucratic urgency and industrial inertia. The Small Arms Committee, the body responsible for weapons procurement, had made a decision even before the .303 guns arrived for testing. They determined that urgency was paramount. War was coming, everyone could see it, and Britain needed to rearm as quickly as possible. The committee ruled that whichever version of the gun was ready for immediate production, .303 or 7.92mm, would be the one adopted. No time would be wasted on conversions or modifications. This decision effectively killed the .303 version. The Birmingham Small Arms Company, known as BSA, had already begun tooling up their factories to produce the 7.92mm version. The production lines were being prepared, the tooling was being manufactured, and workers were being trained. Converting everything to produce a .303 version would require starting over from scratch, delaying production by months or even years. Meanwhile, the political situation in Europe was deteriorating rapidly. Germany had remilitarized the Rhineland in 1936, formed the Rome-Berlin axis with Italy, and was clearly preparing for expansion. Austria would be annexed in March 1938. Czechoslovakia itself would fall in 1939. Britain needed tanks, and those tanks needed machine guns. There was no time to waste on ammunition standardization. In 1938, the British War Office officially ordered the ZB-53 in its original 7.92mm chambering. BSA signed a licensing agreement with Czechoslovakia's Československa Zbrojovka to manufacture the weapon in the UK. The company name, Birmingham Small Arms, was abbreviated as BSA, but when spoken it sounded like Bessa, and so the weapon became known as the Bessa machine gun. Production began in 1939 at BSA's factory in Small Heath, Birmingham. The British made some modifications to suit their needs. They removed the air cooling fins from the barrel casing, simplified some components for easier mass production, and adapted the mounting systems for British tank designs. But the core design remained faithful to Holeck's original. The decision to retain the 7.92mm caliber was justified with several arguments. First, the Royal Armoured Corps already maintained separate supply chains from the infantry, so one more caliber wouldn't significantly complicate logistics. Second, and perhaps more optimistically, captured German ammunition could theoretically be used in an emergency. This latter point was more hope than practical reality, as German and British ammunition markings differed, and quality control issues made using enemy ammunition risky. The first Besa guns entered service in June 1940 as the Mark I variant. These retained the original rate of fire selector, allowing operators to choose between 450 to 550 rounds per minute for long-range work, or 750 to 850 rounds per minute for close combat. The weapon was belt-fed from 225-round metal link belts, providing sustained firepower without the need to change magazines. Each gun weighed approximately 47 pounds, though later production models would increase to 54 pounds as weight. Saving measures were abandoned to speed manufacturing. The Besa fired from an open bolt using a gas-operated air-cooled mechanism, but what made it unique among machine guns was a feature carried over from the Czech original. The barrel actually recoiled slightly when fired, sliding backward against a spring before returning forward. This recoil was carefully synchronized with the bolt movement, so that each round was fired while the barrel was still moving forward. The recoil impulse of firing and the forward momentum of the barrel partially cancelled each other out, dramatically reducing felt recoil and improving accuracy. This made the Besa one of the most accurate tank-mounted machine guns of the war. The ammunition types available for the Besa gave it versatility in combat. Ball ammunition was standard for general-purpose machine gun work against infantry and soft targets. Armour-piercing rounds had a hardened steel core capable of defeating 11 mm of steel plate at close range, making them effective against gun shields, light vehicles, and fortified positions. Tracer ammunition allowed gunners to observe their fall of shot and adjust fire onto target, and incendiary rounds contained compositions that burned at 3,000 degrees Fahrenheit, capable of igniting fuel and ammunition in enemy vehicles. Mixed belts were commonly issued, with combinations like 2 ball, 2 tracer, 3 armour-piercing, and 1 incendiary repeating throughout the 225 round belt. This gave tank crews the flexibility to engage whatever targets they encountered without changing ammunition. The muzzle velocity was approximately 2,180 feet per second, giving the rounds good range and penetration. Effective range against point targets was around 800 yards, while area suppression fire could reach beyond 2,000 yards. By June 1940, an improved Mark II version entered production. This variant featured a refined receiver, a flash suppressor on the barrel, and improvements to the ammunition feed mechanism. But the most significant change came in August 1941 with the Mark III. As the war escalated and production demands increased, Besa simplified the design to speed manufacturing. The Mark III eliminated the rate of fire selector entirely. Guns were produced in 2 fixed-rate variants. The Mark III with a high rate of 750 to 850 rounds per minute, and the Mark III Star with a low rate of 450 to 550 rounds per minute. This change reduced manufacturing time and complexity, while still providing the different rate options. Tank units simply mounted whichever version suited their tactical needs. These simplifications were crucial because by 1941, virtually every British tank rolling off production lines needed at least 1 Besa, and often 2 or 3. The Besa was installed as a coaxial machine gun next to the main gun in the turret, allowing it to be aimed using the tank's main gun sights. It was mounted as a bow machine gun in the hull, operated by the hull gunner or radio operator, and it was sometimes fitted on turret pintle mounts for anti-aircraft defence. The Valentine tank carried 1 Besa coaxially and often another in the hull. The Matilda Mark II had a coaxial Besa partnered with its 2-pounder main gun. The Crusader cruiser tank mounted Bessas in multiple positions. Even the massive Churchill infantry tank with its thick armour and heavy main gun relied on Bessas for anti-infantry work. American-supplied tanks like the Sherman often had their Browning machine guns replaced with Besas when issued to British units, maintaining ammunition commonality within the Royal Armoured Corps. By 1943, the Bessa had become the standard secondary armament for virtually every British tank in service. Production would eventually reach approximately 59,000 units by the end of the war, making it one of the most widely manufactured tank machine guns of World War II. But there was another Besa, larger and far more powerful. In parallel with the 7.92mm version, Besa developed a heavy machine gun based on the Czech ZB60. This weapon, known as the 15mm Besa, was essentially an upscaled version of the standard gun chambered for the massive 15 by 104mm cartridge. The 15mm Bessa fired a 75-gram bullet at 900 meters per second, delivering kinetic energy exceeding a Browning 50 caliber machine gun by more than 50%. This was not simply a heavy machine gun, it was practically an automatic cannon, capable of penetrating light armour and absolutely devastating to unarmoured vehicles, aircraft and personnel. The weapon was introduced in British service in June 1940 and was mounted on the light tank Mark Vic and on armoured cars like the Humber. It could be fired in semi-automatic mode for precise shooting, or in full automatic at approximately 450 rounds per minute. The 15mm Besa was fed from 25-round metal belts, which limited its sustained fire capability, but the weapon was typically used for single-aimed shots rather than bursts. The size and weight of the 15mm Besa, approximately 125 pounds, meant it could only be fitted in vehicles with sufficient mounting space and structural strength. Its recoil was substantial enough that firing full automatic from light vehicles was difficult to control. Crews preferred the semi-automatic mode, carefully picking targets and delivering single devastating hits. Against aircraft, the 15mm was formidable. Against light armoured vehicles, it was deadly. But production numbers remained limited, with only about 3,218 units manufactured before the weapon was declared obsolete in 1949, superseded by proper autocannons like the 20mm Polston. The 15mm Bessa was a fascinating might-have-been, a weapon that showed the potential of the Czech design when scaled up, but ultimately produced in too few numbers to make a significant impact on the war. The standard 7.92mm Bessa, however, went everywhere British tanks went, and that meant it saw combat in some of the most brutal fighting of World War II. Its first taste of action came in France in 1940. The 7th Royal Tank Regiment took Matilda Mark II tanks equipped with Bessas into battle during the defence of France and the desperate fighting around Dunkirk. The Matilda's heavy armour made it nearly immune to most German anti-tank guns of the period, and its Besa provided suppressive fire against German infantry. At the Battle of Arras on May 21, 1940, British Matildas counterattacked German forces, and the Bessas played a crucial role in suppressing anti-tank gun crews and infantry. But France was lost, and the Matildas that survived were abandoned on the beaches when the British Expeditionary Force evacuated. The Besa's true proving ground came in North Africa, where British tanks faced Italian and then German forces across hundreds of miles of desert. In late 1940, during Operation Compass, Matilda tanks of the 7th Armoured Division wreaked havoc among Italian forces in Egypt. The Italians were equipped with L3 tankettes and M1139 medium tanks, neither of which stood a chance against the heavily armoured Matildas. But it was the Bessa machine gun that often did the killing. Italian gunners discovered that their artillery shells bounced harmlessly off the Matilda's thick armour, while the British tanks methodically advanced, their Bessas cutting down exposed gun crews and infantry. The Matilda earned the nickname Queen of the Desert during this period, and the Bessa was her sting. When the German Afrika Korps arrived in North Africa in 1941, the situation became far more challenging. German forces brought the feared 88mm anti-aircraft gun, which could penetrate the Matilda's armour at long range, and the 50mm PaK-38 anti-tank gun provided German infantry with an effective counter. British tankers learned that survival depended on suppressing these gun crews before they could take aim, and that meant aggressive use of machine gun fire. The Besa became the weapon of choice for engaging German anti-tank guns. A tank would advance at speed, the commander watching for muzzle flashes or the telltale dust of gun positions. The moment a German gun was spotted, the Besa would open fire, hosing the position with hundreds of rounds, forcing the crew to take cover while the tank manoeuvred for a shot with its main gun. This tactic saved countless British tanks and crews throughout the Desert War. But there were limits to what the Besa could achieve. In March 1943, members of the 51st Battalion Royal Tank Regiment fighting in Tunisia decided to conduct some unofficial tests. They had been taking heavy casualties from German anti-tank guns, particularly the 50mm, 75mm and 88mm weapons that dominated the battlefield. The tanks often managed to hit these guns with machine gun fire, evidenced by bullet strikes on their gun shields, but the crews seemed to survive and keep fighting. The tankers needed to know if their Bessas were actually capable of defeating the armour that protected German gun crews. They acquired several captured German anti-tank guns and set up a firing range. The 75mm PaK-40, the most common German anti-tank gun by 1943, had a gun shield made of 25mm steel plates separated by a 25 to 38mm air gap. In theory, the Besa's armour-piercing ammunition, which could defeat 11mm of solid steel plates 70% of the time, should be able to penetrate both plates since each was only 5mm thick. The reality was disappointing. When they fired at the German gun shields from combat ranges, the Besa struggled. The problem was the angle. Tank-mounted machine guns were firing from low positions, hitting the angled gun shields at oblique angles that increased the effective thickness of the armour. Even when rounds did penetrate the first plate, they often lacked the energy to defeat the second plate. The conclusion was sobering. The Bessa 7.92mm armour-piercing ammunition was inadequate for reliably killing German anti-tank gun crews by defeating their gun shields at practical combat ranges. They then tested captured German 7.92mm armour-piercing ammunition, identifiable by red and green bands on the bullets. These German rounds performed slightly better, achieving penetration of the 88mm gun's 10mm shield at 50 yards. But upon penetration, the German rounds tended to break up, leaving fragments embedded in the shield. The practical reality was clear. The Bessa was not an anti-tank weapon. It could not reliably defeat armoured gun shields. Its role was suppression, forcing enemy gunners to keep their heads down, disrupting their aim, and buying time for the tank to manoeuvre or for the main gun to engage. But what the Bessa could do, it did superbly. Against unarmoured targets, soft-skinned vehicles, infantry in the open, and lightly protected field positions, it was devastating. The high rate of fire version could put 800 rounds downrange in a single minute. That translated to more than 13 rounds per second, creating a near-continuous stream of bullets. Tank gunners described the effect as a visible line of tracers reaching out toward the target, with every fifth round burning bright red as it flew. Enemy infantry caught in the open by Bessa fire rarely survived. The combination of rate of fire, accuracy, and the power of the 7.92mm round meant that anything not behind solid cover was in mortal danger. During Operation Crusader in November 1941, the operation to relieve the besieged port of Tobruk, Matilda and Valentine tanks equipped with Bessas played crucial roles. On November 27, 1941, tanks from the 7th Royal Tank Regiment's 32nd Army Tank Brigade broke through to link up with the Tobruk garrison. The fighting was brutal, with German and Italian forces counterattacking repeatedly. The British infantry tanks, slow but heavily armoured, advanced methodically while their Besa suppressed enemy positions. German infantry combat reports from this period express frustration at the impotence of their weapons against the Matildas. Small arms fire bounced off uselessly, while the British machine guns seemed to reach everywhere. Even late in 1941, more than a year after the campaign began, German units were reporting that ill-equipped infantry had no effective answer to the British infantry tanks. The Besa also found use in more unconventional roles. Photographs from 1943 show universal carriers, the small tracked vehicles used for reconnaissance and transport, fitted with Besa machine guns on improvised mounts. New Zealand troops in North Africa and later in Italy used these armed carriers for rapid fire support, the vehicles racing forward to firing positions and unleashing bursts of machine gun fire before withdrawing. By 1944, similar setups appeared in northwest Europe, with reconnaissance corps units in Holland mounting Bessa on carriers for screening operations and patrol work. The weapon's reliability and sustained fire capability made it ideal for these roles, even if it meant occasionally removing Besas from damaged tanks to refit onto other vehicles. As the war progressed, new British tanks entered service, and the Besa went with them. The Cromwell cruiser tank, Britain's answer to German medium tanks like the Panzer IV, carried a Besa coaxially in its turret. The Cromwell combined speed, reasonable armour, and the effective 75mm main gun, and its Besa provided close-in defence against infantry. The Churchill infantry tank, with its distinctive long hull and heavy armour, mounted Besas in both the turret and hull positions. The Churchill would become famous for its ability to climb seemingly impossible slopes and obstacles, a trait that proved invaluable in Italy and northwest Europe. As Churchills climbed hills that other tanks couldn't assault, their Bessas provided suppressive fire against enemy positions on the heights. When American M4 Sherman tanks began arriving in British service through Lend-Lease, many had their Browning 30 caliber machine guns replaced with Besas. This maintained ammunition compatibility within British units and simplified logistics. The Sherman Firefly, the British variant armed with the powerful 17-pounder anti-tank gun, also carried Besas. These conversions required manufactured adapters and mounting brackets, but the effort was considered worthwhile to maintain standardization. By mid-war, a British armoured regiment might field Churchills, Cromwells, Shermans and specialised vehicles, but they would all be firing the same 7.92mm ammunition through their Bessas. The invasion of Sicily and Italy in 1943 brought new challenges. The mountainous terrain favoured defenders, and German forces made excellent use of prepared positions, anti-tank guns, and infantry strongpoints. British tanks advancing up narrow Italian roads faced ambushes at every turn. The Besa became crucial for reconnaissance by fire, spraying suspected enemy positions with machine gun fire to provoke a response and reveal hidden guns. Tank commanders would order their gunners to hose tree lines, buildings, and suspicious terrain features. If tracers sparked off hidden steel, or if return fire came back, they'd found the enemy. The main gun could then engage while the Besa continued suppressive fire. The Italian campaign also saw some of the most brutal close-quarters tank fighting of the war. In towns and villages, tanks operated in confined spaces with limited visibility. German Panzerfausts, the shoulder-fired anti-tank weapons, could destroy any tank at close range, and the Germans became adept at ambushing British armour in urban terrain. Besas mounted on turret pintles became lifesavers, allowing tank commanders to engage infantry in upper-storey windows and rooftops. The ability to rapidly traverse and elevate the machine gun, combined with its high rate of fire, made these pintle-mounted Besas essential for urban combat survival. The build-up for Operation Overlord, the invasion of Normandy, saw British armoured forces equipped to unprecedented levels. Thousands of tanks waited in England, and virtually all of them carried Bessas. The 7th Armoured Division, the famous Desert Rats who had fought across North Africa, now prepared to return to France. The Guards Armoured Division, the 11th Armoured Division, and numerous independent armoured brigades all checked and rechecked their vehicles. Armourers loaded ammunition belts, mixing ball, tracer, and armour-piercing rounds in the prescribed ratios. Tank crews practiced firing their Bessas, learning the rhythm of burst fire, the techniques for engaging moving targets, and the methods for clearing jammed weapons. On June 6, 1944, British tanks came ashore on Golden Sword beaches. Specialised armoured vehicles, including flail tanks for clearing mines, and Churchill Avras for demolishing fortifications, all carried Bessas for self-defence. As the tanks pushed inland through the Normandy bocage, that landscape of small fields enclosed by thick hedgerows, the Bessa proved its worth again. The hedgerows provided perfect concealment for German infantry, armed with Panzerfausts and Panzerschrecks. British tanks learned to advance cautiously, their Bessa firing into each hedgerow before crossing it. The machine gun fire might not kill hidden infantry, but it kept them suppressed long enough for the tank to cross the danger area. The fighting in Normandy was grinding and attritional. German forces defended every field, every village, every crossroad. British tank casualties were heavy, with Panthers and Tigers destroying Shermans and Cromwells at long range. But the Besa kept working. After months of continuous combat, with tanks operating in mud, rain, and the dust of summer, the Besas maintained their reputation for reliability. Compared to some other nations, machine guns, which required constant maintenance and frequent replacement of worn parts, the Besa just kept firing. The air-cooled design meant no worrying about water in freezing weather. The belt feed system was robust enough to work even when dust and dirt contaminated the ammunition, and the changeable barrel system meant that overheated barrels could be swapped out in minutes, keeping the weapon in action. As Allied forces broke out of Normandy and raced across France in August 1944, British tanks found themselves in pursuit of retreating German forces. Columns of German vehicles clogged the roads, and Allied aircraft and tanks inflicted terrible casualties. Cromwells and Shermans, faster than the heavily armoured Churchills, raced ahead to cut off retreating Germans. When they caught German columns, the Bessas did much of the killing. Soft-skinned trucks, half-tracks, and even horse-drawn wagons were torn apart by sustained machine gun fire. At ranges too close for effective use of high-explosive shells, and against targets too numerous to engage individually with the main gun, the Bessa's sustained fire capability became a force multiplier. The final campaigns in northwest Europe, from the autumn of 1944 through Germany's surrender in May 1945, saw British tanks equipped with Bessas fighting through Holland, Belgium, and into Germany itself. The Bessa proved equally effective in the flat polders of Holland, the forests of the Ardennes, and the urban ruins of German cities. Tank crews developed an almost affectionate relationship with their Bessas. Unlike the tank's main gun, which was rationed in its ammunition and only fired at significant targets, the Besa was always there, always ready, always reliable. Commanders knew that if they spotted enemy infantry or a suspicious position, they could simply press the trigger and let the Besa sort it out. The weapon became an extension of the tank's senses, used for reconnaissance, for suppression, for destruction, and sometimes just for reassurance in the chaos of combat. But for all its success, the Besa had limitations that were becoming increasingly apparent by war's end. The 7.92mm round, while effective against infantry and light vehicles, lacked the punch to deal with the heavily armoured German tanks that dominated the late war battlefield. German infantry learned that they were relatively safe from Bessas if they could take cover behind solid obstacles. The weapon's anti-aircraft capability, never particularly strong due to its vehicle-mounted configuration and limited elevation, was nearly useless against the increasing speeds of late-war aircraft. And the ammunition situation, maintaining supplies of 7.92mm for the Bessas, while the rest of the British military used .303, remained a logistical complication that would only get worse in peacetime. The British military was already looking toward the future. American Browning .30 caliber machine guns were available in large numbers. They used ammunition that was closer to British standards, and many American supplied vehicles already came equipped with them. The question was not if the Bessa would be replaced, but when. In the immediate post-war period, however, the Bessa soldiered on. British forces in occupied Germany kept their tanks combat-ready, and those tanks still mounted Bessas. The weapon remained in service through the late 1940s and into the 1950s. Post-war variants included the Mark III-2, introduced in 1952, which featured updated mounting brackets and body covers for improved compatibility with newer tank sights. The Mark III-3, introduced in 1954, incorporated a revised barrel and enlarged gas vents to better handle mixed ammunition belts. The Centurion tank, Britain's new main battle tank that entered service just as World War II ended, was initially equipped with Besas. Early production Centurions had a coaxial Besa in the turret, paired with their powerful 17-pounder or later 20-pounder main guns. Centurion, supplied to Commonwealth nations like Australia, New Zealand and India, carried these Besa-armed variants. It wasn't until the mid to late 1950s that the Centurion transitioned to Browning machine guns, marking the beginning of the end for the Besa. The earlier wartime Mark I, Mark III and Mark II Star versions were declared obsolete in 1951. The remaining Mark III guns were converted to Mark III Star Standard, and these later models remained in service until the late 1960s. By that time, the Besa was truly an anachronism, a weapon designed in the 1930s still serving in the age of guided missiles and composite armour. When we evaluate the Besa's contribution to the British war effort, several factors stand out. First, its reliability was exemplary. In an environment where complexity meant vulnerability, where dirt, mud and sand destroyed precision mechanisms, the Besa kept working. Tank crews in North Africa reported Besas functioning after months in the desert. Crews in northwest Europe praised the weapon's performance in freezing rain and thick mud. This reliability was not accidental. It was the result of Holeck's brilliant design and BSA's precision manufacturing. Second, the weapon's accuracy was remarkable for a vehicle-mounted machine gun. The recoiling barrel system that partially countered recoil, combined with robust construction and precise manufacturing tolerances, made the Besa capable of accurate fire at ranges that surprised even experienced gunners. Reports speak of Bessas hitting targets at 800 yards and beyond, distances where many other machine guns were reduced to area fire. Third, the sustained fire capability gave British tanks a tremendous advantage in infantry support roles. A Besa with a fresh barrel and adequate ammunition could fire almost continuously for minutes at a time. This wasn't theoretical. Tank crews in Italy and northwest Europe would sometimes expend thousands of rounds in a single engagement, their Bessas, providing a base of fire that pinned down German infantry while friendly forces manoeuvred. The belt feed system and changeable barrels made this sustained fire practical in ways that magazine-fed weapons simply could not match. Fourth, and perhaps most important, the weapon was there when it was needed. In 1939, as Britain scrambled to rearm, the decision to adopt the Bessa in its original 7.92mm chambering, despite the ammunition complications, meant that British tanks could be equipped with an effective machine gun immediately. Had Britain insisted on converting the design to .303, production would have been delayed by months or years, leaving tanks without adequate secondary armament during critical early campaigns. The ammunition situation that seemed like such a compromise in 1939 turned out to be manageable in practice. The Royal Armoured Corps did maintain separate supply chains, and adding 7.92mm ammunition to those chains was less disruptive than feared. The theoretical advantage of using captured German ammunition rarely materialized in practice, due to quality concerns and the risks of mixing ammunition types, but it remained a useful backup in emergencies. By 1940, British factories were producing 7.92mm ammunition in sufficient quantities to meet demand. Lake City Arsenal and other facilities manufactured millions of rounds monthly, ensuring that British tanks never ran short of Besa ammunition. The production numbers tell their own story. Approximately 59,000 7.92mm Besas were manufactured during the war years, plus another 3,200 or so of the 15mm variant. This made the Besa one of the most widely produced tank machine guns of World War II. Every major British tank design from 1940 onward either came equipped with Besas or could be easily fitted with them. This standardization simplified training, maintenance and logistics across the Royal Armoured Corps. A tank crewman trained on a Matilda's Besa could transfer to a Churchill or Cromwell and find the same weapon system, operated in exactly the same way. The human element should not be forgotten. For the thousands of British tank crewmen who served in World War II, the Besa was a constant companion. Loader operators in the turret, hull gunners in the bow, and commanders manning pintle mounts all learned the distinctive sound of the Besa's high rate of fire, the feel of the weapon's recoil transmitted through the tank's structure, and the acrid smell of propellant smoke that filled the crew compartment after sustained firing. They learned to clear jams, to change barrels when they glowed red hot, to load ammunition belts in the dark by touch, and to know by sound alone when the gun was running low on ammunition. These skills, taught in training camps in England and refined in combat from North Africa to Germany, represented thousands of hours of collective experience with a weapon system that proved worthy of their trust. In this wider context of armoured warfare development, the Besa represents an interesting case study. It was not revolutionary. It introduced no radical new technologies or unprecedented capabilities. It was in many ways simply a very good implementation of existing machine gun technology, adapted specifically for tank mounting. But that adaptation mattered. The air cooling, the belt feed, the changeable barrel, the recoil damping system, and the robust construction all combined to create a weapon that was greater than the sum of its parts. It worked when and where it was needed, and in wartime, that is the highest praise any weapon can receive. The comparison with other nations' tank machine guns is instructive. German tanks primarily used the MG-34 and later MG-42, both excellent weapons but designed primarily for infantry use and adapted for vehicle mounting. American tanks used the Browning .30 caliber, a reliable weapon but one that lacked the Bessa's accuracy at longer ranges. Soviet tanks used variants of the Degtyaryov machine gun, robust and simple but less refined than the Besa. The Besa stood out for being designed from the beginning as a vehicle weapon, with all the considerations that implied. The Czech origins of the Besa add another dimension to its story. Václav Holek and Miroslav Rolčík, working in Czechoslovakia in the 1930s, could not have imagined that their creation would equip the armoured forces of the British Empire and serve in campaigns across 3 continents. The fact that their weapon, originally designated ZB-53, achieved such success is a testament to the quality of Czech firearms engineering in the interwar period. It also represents one of the many ironies of World War II that a German-caliber weapon, designed in Czechoslovakia, manufactured in Britain, would be used so effectively against German forces. Today, surviving Besa machine guns are prized by collectors and museums. The Imperial War Museum in London has several examples, including both 7.92mm and 15mm variants. The Tank Museum at Bovington displays Bessas mounted in restored Valentine, Matilda, Churchill and Cromwell tanks, showing visitors how the weapon was actually installed and operated. Military reference works and small arms encyclopedias accord the Besa a place of respect, noting its reliability and effectiveness while acknowledging its limitations. The handful of Besas that remain in firing condition are occasionally demonstrated at military history events, where their distinctive sound, a rapid mechanical chatter quite different from the American Browning's slower cadence, reminds us of how these weapons once sounded across the battlefields of World War II. In the final analysis, the Besa machine gun was a success precisely because it was thoroughly competent, rather than brilliantly innovative. It did not revolutionize armoured warfare. It did not win battles single-handedly, but it worked reliably across 5 years of global war in environments ranging from scorching deserts to frozen forests, operated by crews who ranged from highly trained professionals to hastily trained conscripts, and it rarely let them down. For a weapon adopted out of urgency, Built under wartime conditions and used in some of the most demanding combat imaginable, that record of steady competence represents a greater achievement than any amount of technical brilliance could have provided. The Besa machine gun was there when British tankers needed it, and in the end, that is what mattered most. The story of the Besa's combat employment reveals layers of tactical evolution that often go unnoticed in broader histories of armoured warfare. When British tank crews first received the weapon in 1940, most had been trained on the water-cooled Vickers, a weapon whose operational characteristics were entirely different. The Vickers required careful management of water temperature, periodic refilling of cooling jackets, and a methodical approach to sustained fire. The Besa, by contrast, demanded a different mindset. Air-cooled weapons built heat rapidly, and while the barrel could be changed, doing so inside a cramped tank turret while under fire was a delicate operation that could go wrong in countless ways. Training establishments in Britain developed specific courses for Besa operation. At the Armoured Fighting Vehicle School at Bovington, instructors taught the critical skills, loading the 225-round belts into the ammunition boxes without kinking the links, threading the belt through the feed mechanism correctly, ensuring the first round was properly seated, setting the sights for different ranges, compensating for the trajectory of the 7.92mm round. Most critically, they taught fire discipline. A gunner who held down the trigger for too long would heat the barrel to the point where ammunition could cook off in the chamber, causing a runaway gun that fired continuously until the belt was exhausted. Controlled bursts, typically 5 to 7 rounds, were the doctrine. Long enough to observe tracer fall and adjust aim, short enough to manage barrel temperature. But doctrine and reality diverged in combat. Tank gunners in North Africa quickly learned that German and Italian infantry would go to ground at the first burst of machine gun fire, then resume advancing once the firing stopped. Keeping the enemy pinned required sustained fire, and that meant longer bursts than the training manuals recommended. Crews developed techniques to manage this. The loader would keep a spare barrel ready, wrapped in a wet cloth to prevent burns when handling it. When the gunner reported the barrel was overheating, indicated by a change in the weapon's sound and feel, the loader would execute a rapid barrel change. In a well-drilled crew, this could be accomplished in under 30 seconds. The hot barrel would be set aside to cool while the fresh barrel took over. Some tanks carried 3 or 4 spare barrels, allowing them to maintain almost continuous fire by rotating through the barrels. The coaxial mounting of the Besa, fixed parallel to the main gun and aimed using the same sights, created both advantages and constraints. The advantage was precision. When the gunner had the main gun laid on target, the Besa was automatically aligned as well. This made the machine gun devastatingly accurate at medium ranges, far more so than hull-mounted guns that required separate aiming. But the constraint was flexibility. The coaxial Besa could only engage targets within the turret's traverse and elevation limits. In close terrain, particularly in urban fighting or when ambushed from the flanks, this limitation could be fatal. German infantry learned to attack British tanks from directions where the turret couldn't quickly traverse, exploiting the momentary vulnerability while the tank commander tried to bring guns to bear. This led to the increased use of pintle-mounted Besas on turret roofs, particularly from 1943 onward. These mounts allowed all-around traverse and higher elevation angles, making them useful for both anti-aircraft defence and for engaging infantry in buildings or on elevated terrain. The 7th Armoured Division in Italy made extensive use of pintle-mounted Bessas during the fighting in the Apennine Mountains, where German positions on hilltops had to be engaged at steep angles. Churchill tanks climbing the slopes of Monte Cassino used their turret-mounted Bessas to suppress German machine gun nests and observation posts that their coaxial guns couldn't reach. The pintle mount came with its own risks. The commander had to expose himself above the turret to operate it, making him vulnerable to snipers and artillery fragments. Many tank commanders were killed or wounded while manning their pintle guns. But the tactical necessity often outweighed the risk, particularly in situations where the alternative was allowing enemy infantry to close to Panzerfaust range. The effectiveness of the Bessa against different target types varied considerably and was the subject of ongoing analysis throughout the war. Against infantry in the open, the weapon was lethal at all practical ranges. The 7.92mm round had sufficient energy to inflict fatal wounds out to 1,000 yards, and the Bessa's accuracy meant that aimed fire could hit individual soldiers at 600 to 800 yards. Mixed ammunition belts with tracer rounds allowed gunners to walk their fire onto targets, adjusting for range and wind. Against infantry in prepared positions, trenches, or behind cover, the Bessa's effectiveness dropped significantly. The 7.92mm round lacked the mass and energy to penetrate substantial earth or masonry fortifications. Gunners learned to look for gaps and openings, firing bursts into vision slits, firing ports and doorways in hopes of catching enemy soldiers when they exposed themselves. Against soft-skinned vehicles, trucks, half-tracks, and unarmoured cars, the Besa was highly effective. The armour-piercing ammunition could penetrate engine blocks at reasonable ranges, and even ball ammunition could shred sheet metal bodywork, tyres, and windscreens. Combat reports from the breakout from Normandy in August 1944 describe British tank columns engaging German transport convoys, with Besa setting vehicles ablaze or disabling them with concentrated fire into engines and fuel tanks. The incendiary rounds in mixed belts were particularly effective here, igniting fuel and ammunition when they penetrated vehicle bodies. Against armoured vehicles, the Besa's utility was limited but not non-existent. As the unofficial testing by the 51st Battalion Royal Tank Regiment had demonstrated, the weapon could not reliably penetrate German anti-tank gun shields at combat ranges and angles. Against actual tanks, the Besa was essentially useless for penetrating armour, but it had other applications. Tank commanders would use Besa fire to suppress the vision of enemy tank crews, raking opposing tanks with machine gun fire to force commanders to button up and close their hatches. This reduced the enemy crew's situational awareness and made them more vulnerable to flanking manoeuvres. Some British tankers reported using Besa fire to damage the external fittings on German tanks, particularly periscopes, vision blocks, and radio antennas. Whether this actually degraded enemy tank effectiveness is debatable, but the psychological impact of being under sustained machine gun fire while buttoned up in a tank was significant. The Besa also found employment in the anti-aircraft role, though this was always a secondary mission. Tank-mounted machine guns face severe limitations when engaging aircraft. The mounting usually restricted elevation to 45 degrees or less, inadequate for engaging aircraft passing directly overhead. The sights were calibrated for ground targets, not for the deflection shooting required against fast-moving aircraft. And coordinating fire between multiple tanks to create an effective anti-aircraft barrage required communications and training that most tank units lacked. Despite these limitations, British tank units did engage aircraft with their Bessas when the opportunity arose. During the North African campaign, Italian CR-42 biplane fighters and German Ju-87 Stuka dive bombers occasionally flew low enough to be engaged. The high rate of fire version of the Besa, putting out 750 to 850 rounds per minute, could create enough volume of fire to deter low-flying aircraft even if actual kills were rare. One documented incident from Tunisia in March 1943 involved a troop of Crusader tanks from the 9th Lancers that engaged a formation of Stukas attacking British positions. The 4 tanks formed up in a rough square and opened fire with all available Besas, including coaxial and pintle-mounted guns. The concentrated fire, thousands of rounds per minute rising into the sky in streams of tracers, forced the Stukas to break off their attack runs and climb to safer altitudes. No aircraft were confirmed shot down, but the mission was disrupted, and the British positions escaped bombing. This became the model for defensive anti-aircraft fire from tank units. Not to shoot down aircraft, which was a bonus if it happened, but to make low-level attack runs so dangerous and uncomfortable that enemy pilots would abandon them. The ammunition logistics for the Besa represented a significant undertaking that deserves examination. By 1944, British armoured divisions in northwest Europe were consuming staggering quantities of 7.92mm ammunition. A typical armoured regiment of 3 squadrons, fielding around 50 to 60 tanks, might fire 100,000 rounds of Besa ammunition in a single day of heavy combat. Over a month of operations, consumption could reach several million rounds. This ammunition had to be manufactured, shipped to Europe, distributed to forward supply points, and delivered to individual tanks, all while maintaining the flow of other essential supplies like fuel, main gun ammunition, food, and spare parts. The solution involved dedicated ammunition supply columns and carefully organised logistics chains. Divisional ammunition points held stocks of all ammunition types, including separate reserves of 7.92mm for the Besas and 303 for the infantry's Bren guns and rifles. Regimental supply echelons would draw ammunition daily, loading it onto trucks that would move forward to replenishment points behind the fighting. Individual tanks would pull back from the line in rotation to rearm, with crews manhandling the heavy ammunition boxes from supply trucks into their vehicles. Each tank typically carried around 400 to 500 rounds of Besa ammunition in loaded belts, stored in armoured boxes within the hull and turret. This represented roughly 20 225-round belts, enough for several engagements but not an unlimited supply. Expended ammunition belts posed their own logistical challenge. The metal link belts, once fired, had to be collected and either discarded or sent back for refurbishment and reuse. Some units simply threw away expended belts, treating them as consumables. Others, more conscious of metal conservation, collected them in bins for eventual return to depots. The decision often came down to tactical situation. Units in active combat discarded belts to save time and space. Units in static positions or reserve would collect them. By late 1944, with supply lines stretching from Britain through France and into Belgium and Germany, even small efficiencies in ammunition logistics mattered. The maintenance of Bessa machine guns in field conditions revealed both the weapon's robust design and the challenges of keeping any precision mechanism functional in combat. Tank workshops at regimental and divisional levels maintained stocks of spare parts, spare barrels, replacement feed mechanisms, and the specialized tools needed for Besa maintenance. The weapons. Design, while reliable, still required periodic servicing. The gas system needed cleaning to remove carbon fouling. The feed mechanism required lubrication, but not too much, as excess oil would attract dust and grit. The barrel, after prolonged firing, would show throat erosion that degraded accuracy. Armourers learned to gauge barrel condition by measuring the bore diameter at several points and by examining the rifling for wear. Replacing worn barrels was straightforward in depot conditions but complicated in the field. The barrel was held in place by a locking collar that required a specialized wrench to remove. In theory, tank crews carried this tool, but in practice tools went missing, were used for other purposes, or were simply lost in the chaos of combat. Armourers improvised, creating makeshift wrenches from steel stock or adapting tools from other weapon systems. Once removed, the old barrel was marked as unserviceable and sent back through the supply chain for refurbishment or scrapping. The new barrel had to be head-spaced correctly, ensuring proper alignment with the bolt face. If the head spacing was wrong, the gun would either fail to fire or worse, suffer a catastrophic failure that could injure the crew. Stoppages and malfunctions, while rare with the Besa, did occur and had to be dealt with quickly, often under fire. The immediate action drill taught to every tank gunner and loader followed a simple sequence. First, attempt to recock the weapon by pulling the charging handle. This often cleared minor feed issues or failures to fully cycle. Second, if recocking failed, open the feed cover and inspect the chamber and feed mechanism. Common problems included kinked ammunition belts, bullets that had pulled partially out of their cases, or links that had jammed in the feed mechanism. The loader would clear the obstruction, discard the damaged rounds, and reload. Third, if the weapon still refused to fire, check for a broken firing pin or other mechanical failure that required armourer attention. Some stoppages were more serious. A cook-off, where heat from sustained firing ignited a round in the chamber without the firing pin striking it, was dangerous but manageable. The weapon would continue firing until the loaded belt was exhausted. The drill was to keep the gun pointed at the enemy and let it empty itself, then immediately change the barrel before attempting to reload. A burst barrel, caused by an obstruction in the bore, was catastrophic. The barrel would split or even explode, potentially injuring crew members and certainly rendering the weapon inoperable until a replacement barrel could be installed. Burst barrels were rare with the Besa, testament to its robust construction and the quality control in ammunition manufacture. The evolution of Besa employment tactics paralleled the evolution of British armoured doctrine throughout the war. In 1940 and 1941, British armour operated under doctrines that emphasised the separation of infantry tanks and cruiser tanks, with different roles and different tactical approaches. Infantry tanks like the Matilda and Valentine were supposed to support infantry advances, moving slowly and using their armour and machine guns to suppress enemy positions. Cruiser tanks were meant for exploitation and pursuit, engaging enemy armour and racing through gaps in the defence. These doctrinal divisions influenced how Bessas were employed. Infantry tank crews expected to use their machine guns extensively, suppressing enemy positions for prolonged periods. cruiser tank crews anticipated shorter, sharper engagements, using their machine guns primarily for self-defense, while their main guns dealt with enemy tanks. By 1943, combat experience was forcing doctrinal revisions. The artificial distinction between infantry and cruiser tanks was breaking down as the realities of combat proved that all tanks needed to be capable of both infantry support and tank fighting. The arrival of the Cromwell, which combined reasonable armour with good speed and firepower, exemplified this shift. Besa employment evolved accordingly. Tank crews learned to use their machine guns more aggressively, not just for suppression but for reconnaissance by fire, for marking targets for other tanks, and for controlling the tempo of engagements. A well-coordinated tank troop could use concentrated Besa fire to pin enemy anti-tank guns while manoeuvring for main gunshots, or to suppress infantry positions while the tanks advanced. The 1944 campaigns in northwest Europe saw the full maturation of these tactics. British armoured divisions operating in France, Belgium and Holland developed sophisticated combined arms techniques that integrated tanks, infantry, artillery and air support. Within this framework, the Besa played specific roles. During advances, lead tanks would use their Besas to engage suspected enemy positions, forcing the enemy to reveal themselves or remain suppressed. Following tanks would engage confirmed targets with main guns and machine guns. During defensive operations, tanks would establish hull-down positions where only their turrets were exposed, using their Bessas to interdict German infantry and light vehicles, while conserving main gun ammunition for tanks and strong points. The close cooperation between tanks and infantry, refined through painful experience, gave the Besa new importance. Infantry advancing alongside tanks were vulnerable to enemy machine gun fire and mortars. British tankers learned to provide overhead machine gun fire, keeping their Bessas firing just ahead of the advancing infantry to suppress enemy positions. This required excellent fire control and communication between tank commanders and infantry platoon leaders. The traces from Besa fire served as visible markers, showing the infantry where the tanks were engaging and helping coordinate the advance. Infantry, in turn, would mark targets for the tanks, pointing out anti-tank guns, dug-in positions and other threats that tank crews might not spot from inside their vehicles. Urban combat, which British forces encountered frequently from Normandy onward, demanded new techniques. Cities and towns were nightmarish environments for tanks, with limited visibility, restricted manoeuvre space, and countless hiding places for anti-tank weapons. The Besa became a tool for clearing buildings and streets. Tank crews would systematically engage every window, every doorway, every possible firing position with machine gun fire before advancing past it. The technique was called reconnaissance by fire, and while it consumed enormous amounts of ammunition, it saved lives by forcing enemy soldiers to take cover or reveal their positions. The fighting through the Siegfried Line fortifications in late 1944 and early 1945 tested Besa effectiveness against prepared defences. German pillboxes and bunkers, built with thick concrete walls and small firing apertures, were impervious to machine gun fire, but the Besas still had utility. Tank crews would engage the vision slits and firing ports of bunkers, not expecting to penetrate, but to blind the defenders and make it difficult for them to observe or fire accurately. While Bessas kept the bunker suppressed, engineers could advance with demolition charges, flamethrowers, or other specialised equipment to actually destroy the fortification. This became standard procedure, with tanks and infantry working in intimate cooperation to reduce German defences systematically. The final months of the war saw British tanks advancing deep into Germany itself, encountering desperate resistance from Wehrmacht remnants, Volkssturm militia, and Hitler Youth units. The Besa's psychological impact became as important as its physical effects. German defenders, hearing the distinctive sound of British machine guns, often knew they were facing tanks and that their own anti-tank capabilities were limited. Some chose to surrender rather than fight. Others broke and ran. The mere presence of tanks firing their bases was sometimes enough to collapse German defensive positions without the need for main gun engagement. Beyond the Western Front, Bessa saw service in the Mediterranean theatre throughout the war's final years. British tanks in Italy faced some of the most difficult terrain of the entire conflict. The mountainous spine of Italy, with its narrow valleys, steep hillsides and countless rivers, restricted armour operations to roads and valleys where German defenders could establish devastating ambushes. Churchill tanks, with their excellent climbing ability and heavy armour, proved ideal for Italian conditions, and their Bessas were in constant use. Tank crews learned to fire their machine guns upward at extreme angles, engaging German positions on hillsides and ridgelines above them. The Besa's effective elevation in turret mounting was normally limited to perhaps 20 degrees, but in the mountainous terrain, tanks could be positioned on slopes that effectively increased this elevation, allowing engagement of targets high above. The Greek campaign in late 1944, when British forces intervened to support Greek government forces against communist insurgents, saw Bessas employed in yet another role: internal security operations in urban areas. British tanks in Athens used their Bessas for crowd control and for engaging insurgent positions in buildings, working alongside infantry to restore order. This was politically sensitive work, and the use of armoured vehicles against what were technically civilian targets, even armed insurgents, raised questions that reverberate in military ethics discussions to this day. But operationally, the Bessa proved effective in this role, its ability to deliver precision fire, allowing tank commanders to engage specific targets while minimising collateral damage. The post-war period brought both the zenith and decline of Bessa service. In 1945 and 1946, British forces occupied zones in Germany and Austria, maintaining large armoured forces equipped with wartime vehicles. These tanks, including Churchills, Cromwells and Shermans, all mounting Bessas, served as both military forces and visible symbols of Allied victory. Tank crews continued to train with their Bessas, maintaining proficiency even though actual combat had ended. Ammunition stocks built up during wartime were gradually expended in training exercises. The British Army of the Rhine, as occupation forces were designated, held regular live-fire exercises where Bessas rattled across German training ranges, the sound a reminder of recent conflict. But the military was already looking forward. The Centurion tank, which would dominate British armoured forces for decades, represented a new generation of design. Early Centurions retained Bessas, but planning was underway to transition to Browning machine guns. The arguments for replacement were compelling. The Browning 30 caliber used ammunition that was being standardized across NATO forces. American military aid included vast quantities of Browning guns and ammunition, and as British forces downsized from wartime peaks, maintaining separate ammunition production and supply chains for the 7.92mm, Besa became increasingly difficult to justify. The transition was gradual. Through the late 1940s and early 1950s, Bessas remained in frontline service. British forces deployed to Malaya during the emergency, the counter-insurgency campaign against communist guerrillas, took Besa-armed tanks and armoured cars. The jungle terrain limited armour employment, but when tanks could be used, their machine guns proved valuable for engaging ambush positions and providing fire support for infantry patrols. The Korean War saw British tanks, including Centurions and Cromwells, fighting alongside American and other UN forces. Some of these tanks still mounted Bessas, though others had been converted to Brownings. The mixed equipment complicated logistics, as supply officers had to manage ammunition for both weapons. By the mid-1950s, the decision to phase out the Bessa was final. New production tanks came equipped with Brownings. Older tanks were retrofitted during overhaul periods. The Bessa production lines at BSA had shut down, and remaining stocks of weapons were either placed in storage or sold to foreign militaries. Commonwealth nations that had received British tanks often retained their Bessas longer than Britain itself. Indian, Australian, and New Zealand forces continued operating Bessa-armed vehicles into the early 1960s in some cases, gradually replacing them as new equipment arrived or as existing vehicles wore out. The final chapter of Bessa service came in the most unlikely places. As Cold War tensions shaped military aid and arms sales, obsolete British tanks equipped with Bessas found their way to various countries. Egypt received Centurions with Bessas and used them in clashes with Israel in the 1950s. Some South American militaries acquired British tanks with their original Bessa still installed. These weapons, designed in Czechoslovakia in the 1930s, manufactured in Britain during World War II, fought in conflicts that their designers could never have anticipated. The technical legacy of the Bessa influenced British thinking about tank armament for years afterward. The weapon had demonstrated the value of belt-fed, air-cooled machine guns for armoured vehicles. It had proved that high rates of fire were valuable for suppression and intimidation, and it had shown that robust, simple mechanisms could be reliable even under harsh conditions. When Britain developed its own machine gun designs in later years, including the L8 series, designers consciously incorporated lessons learned from Besa experience. The historical assessment of the Besa has evolved over the decades since World War II. Contemporary accounts from the 1940s and 1950s often dismissed it as a compromise weapon, chosen for expedience rather than excellence. The ammunition situation, using German-caliber rounds, was seen as an embarrassing necessity. This view persisted through the 1960s and 1970s as military historians focused on the more glamorous aspects of armoured warfare, main gun duels and strategic campaigns, giving little attention to secondary armament. More recent scholarship has been kinder to the Besa, recognising it as a successful adaptation of an excellent design to British needs. Researchers examining wartime production and logistics have noted that the decision to adopt the 7.92mm version, while creating some complications, was probably correct, given the time pressures of 1938 and 1939. Delaying tank production to wait for a 303 conversion would have been strategically disastrous. Studies of tank crew experiences and tactics have revealed how extensively the Besa was actually used in combat and how highly crews valued its reliability. The Besa represents a particular approach to military procurement that deserves recognition. It was not a cutting-edge, groundbreaking design. It was not the result of extensive research and development. It was simply a very good foreign design, licensed and put into production quickly because it met an urgent need. In an era when nationalism often prevented militaries from adopting foreign weapons, Britain's willingness to use a Czech design shows admirable pragmatism. This same pragmatism led to adopting the American Sherman tank in large numbers, despite some performance shortcomings, because it was available when British production couldn't meet demand. The men who designed, manufactured, maintained, and used the Besa deserve the final word in its assessment. Václav Holek, the Czech engineer who created the Zb-53, lived to see his design serve throughout World War II, though his homeland's occupation by Germany must have been bitter knowledge. The workers at BSA's small Heath factory, many of them women who had never worked in industry before the war, produced nearly 60,000 Besas with remarkable consistency and quality. The armourers and mechanics who maintained the weapons in the field, often working in darkness, in danger, and under terrible conditions, kept them functioning when functioning meant the difference between life and death. And the tank crews, young men from Britain, Canada, Australia, New Zealand, India, South Africa, and every corner of the Commonwealth, who sat behind Bessas in combat, their lives depending on the weapon's reliability. These men left scattered references to the Besa in memoirs, letters, and official reports. Most comments are brief, unremarkable. The machine guns worked well, no stoppages reported, ammunition expenditure heavy but effective. But occasionally someone would write more, a tank commander describing how his Besa's fire saved his troop from an ambush, a gunner praising the weapon's accuracy at ranges he hadn't thought possible, a squadron leader noting in his war diary that not a single Besa in his unit had suffered a critical failure in 6 months of continuous operations. These small testimonies, spread across thousands of documents in archives from London to Canberra, collectively paint a picture of a weapon that worked, that was trusted, and that contributed meaningfully to Allied victory. In the end, the Besa machine gun story is not one of dramatic innovation or revolutionary technology. It is a story of competent engineering, pragmatic procurement, reliable performance, and quiet effectiveness. In a war where equipment failure could mean death, where unreliable weapons cost lives, where complicated designs broke under harsh conditions, the Besa simply worked. It fired when triggers were pressed. It kept firing through dust, mud, heat, and cold. It was there when needed, doing its job without fanfare or drama. For a weapon of war, no higher achievement is possible. The Besa machine gun served British armoured forces, faithfully throughout history's largest conflict, asking nothing and delivering exactly what was needed. That service, that reliability, that quiet competence in the face of mechanical and human demands represents the true measure of its success.